Very good morning. In the today's class, we are going to see about the intelligent nature of the living creature. In the yesterday's class, we have discussed about the intelligent nature of living creatures, and from that, how we are going to take that intelligent optimization techniques of the living creature, and how we are going to utilize that for our engineering problems. There are many engineering problems are there. So even though electrical engineering, then what we are studying is power system engineering. There are many problems are there, and how we are applying that intelligent nature into that particular engineering problem is a very important concern. There are many problems in power systems engineering also there, and like yesterday we have discussed about the intelligent nature of the ants, then your frogs, then as well as your birds and all. In the today's class, we are going to see about the how the honeybees, how it is searching their food particles, and how optimally it is reaching their it is reaching their particular food particles, like that. So if you take the intelligent nature of the honeybees, there might be like king bees might be there, queen bees might be there, then also the scavenger bees might be there. Okay, so king bee and queen bee always sit in into that honeycomb, or their small houses or small places, or the honeycomb. So what it will do is it will simply sit. Okay, the queen bees only will breed. That's all. Okay, queen bees only will breed. So king bee will help the queen bees to breed. That's all. Okay, so king is king. It will sit into the particular honeycomb. So queen bee just it will give the command to the particular scavenger bees. So whether how to go to that particular place, like task, it will assign the task. Okay, so it will not communicate all the things. Okay, so queen bee just sit, you can see the queen bees. Okay, it will be of multicolor. By seeing the bee itself, you can tell like that is a queen bee. Okay, so if you are not aware of that, you can go to the some other honeycomb nearby, place honeycomb nearby. You can see. Okay, once in a while you can see the queen bees, and the scavenger bees will be of very normal, okay, normal color, like gray and brown color, and queen bees are of multicolor. Okay, so this scavenger bees only will go to the particular food particle, in the sense it will go near to the flowers. Okay, the flowers, in the sense in the from the flower it will collect the nectar content. Okay, that nectar only will convert into the your honey. Okay, so it will randomly first, the scavenger bees, what it will do is it will randomly search all the flowers. Okay, say for example 10 flowers are there. Okay, so first what it will do is, say for example scavenger bees are of 150 numbers. Okay, 50 scavenger bees is randomly going, and grouply only going, but randomly it will scatter into random places. And say for example some 20 flowers are there. Okay, 20 flowers are there, so nectar content may be different from the flower to flower. Okay, so sunflower might be there, some rose flower might be there, some daisy flower might be there, some many flowers might be there. Okay, so based on the flower, okay, based on the nectar means in the center part of the flower, one small portion might be there. So the flower will store all the that nectar content in that particular center part only. Okay, so if you see that bee is always sitting into that particular nectar part only. Okay, so what it will do is, that bee will randomly sit on to all the nectars. Okay, based on the nectar content, amount of the nectar content. Say for example, if the nectar is having more amount of that honey content, so the dancing will be more. Okay, if the nectar is having less amount of the less amount of that particular honey content, okay, the content, so the dancing will be lesser. So based on the dancing, okay, based on the dancing, waggle dancing, we can tell that as a waggle dance. Okay, you can also see that a waggle dance. So based on the waggle dance, this like bees will communicate. Okay, this bee will communicate if the waggle dance is more, that bees can able to know that this flower is having more nectar content. So what it will do is all the bees will come to that particular flower, and it will take that nectar amount, and it will go to the particular honeycomb, or that particular small house where we constructed artificially or naturally constructed. So it will go into that particular part in an optimal path. Okay, searching also, it will come into the shortest path, optimal path, and from there, okay, it has to go and it has to take that honey and go to that particular place, and it has to put that thing, and again it has to come back. Okay, even it is 2 kilometers, 3 kilometers also, it will go into shortest path only. Okay, so what you can do is, you can you can grab one small bee, a scavenger bee, and you can keep one small sensor onto that thing, and you can see how it is traveling, how it is you can follow the trajectory of that particular honeybee from here to there, how it is moving, and what path it is moving. So if you draw the trajectory of that particular honeycomb to that particular flower, okay, it might be traveling into the shortest path. Okay, so that is the very intelligent nature of the that particular honeybees. So this kind of optimization techniques are using in many sort of engineering problems. Okay, there are many engineering problems, not only in electrical engineering, as well as mechanical engineering is there, civil engineering is there, then your computer science engineering is there. So many problems, this kind of techniques might be utilized. So we are not taking the exactly what is the thing the bees are using, but we are taking only the intelligent nature of this living creatures, even it is honeybee, even it is ants. So whatever the organism, like living creature may be, that only we are taking. Okay, so whale optimization is there, then that cat optimization is there, lion search optimization is there. So many techniques are there nowadays, many techniques are arising. So whichever is, say for example, bird searching. So if you take the birds searching, always birds will go fly into the groups, to move towards the searching for the particular food particles, will be in the group only. You can see many of the birds, not few birds are different. If you take a majority of the birds will come into group only. 10 birds will come, or 5 birds will come. Okay, it will divide, if it will divide among themselves. Okay, 5 birds or 10 birds, approximately I'm telling, it might be of more also. So say for example, I'm telling some 5 to 10 birds might be coming to the searching that particular food particles. Okay, and it will communicate with their sounds. With their sounds, it will communicate. If the food particle is more, so it will do more sound, so that all the birds will come to that particular place. And so even if that bird is in a very danger zone also, it will okay, sounds like differently. Okay, it sounds like differently, then all the birds also will come to that particular place to rescue that particular bird, like that. Okay, if any accident happen, say for example, you can see some of the birds may hit, like it will go into the transformer, like your distribution transformer, and suddenly some due to short circuit, it may fall down sometimes, or it may immediately, okay, it will fall down. So all the birds, in a very few seconds, you can see, like very few, there's some 10 to 20 seconds, all the birds will come to that particular place to rescue that bird. Okay, so you can see some real time also. So that is the sound, making the sound differently. So all the birds will come to that particular place like that. So even though with the food particle, if the food particle is very very more, you can also take some food particle of some big, some 1 kilogram, something like that, you can place somewhere else outside now. What you will do, will make some sound, so that birds also may come to that particular place. Okay, so that due to that sound, that, yeah, many birds will come. Okay, some maybe after 5 minutes or 10 minutes, many birds will come to that particular place. That birds also make some sound. Okay, so easily it may communicate with the other birds. Okay, so and sometimes if you see, like maybe 20 birds or 30 birds might be also there. Okay, so you can see in front of a mosque, in front of some like public places, what they will do is they will they'll show some grains. So all the your that birds also will come and sit together. So due to that, will make some sound, different sound. So the like and if it will practice na, so daily, say for example, daily morning we are keeping some grains, or daily morning we are keeping some food particles now. It will practice, like morning 6 o'clock sharply, it will come to that particular, that birds, all the together, like group birds will come to that particular place, and it will take that, even though if you keep or not, if you practice like that for 1 or 2 days, then third day, fourth day, like 365 days it will come in the morning, exactly at the say for example, exactly you're keeping at 6 o'clock now, exactly it will come, maybe 1 or 2 minutes, or it might be varying, but exactly it will come to that place, and exactly you can feel that that thing. Okay, so this is also one of the intelligence. So where the food particle is majority available, so it will save in that memory, it will save in that memory, so that particular place it will come. So this is also one kind of optimization techniques that we'll utilize in the different intelligent techniques. So now you may ask some question, why this optimization is need for the engineering problem and the engineering design like that. So designing, if you take like any engineering design, not only engineering design, if you take any designing of any product, okay, any product in the world, if you take like our mobile phones, if you take even a pen, a small ballpoint pen, so how optimized design, if you take like a ballpoint pen, I think you are getting the ballpoint pen now at even 1 rupee also, 2 rupees also, 5 rupees also, 50 rupees also, then 100 rupees also, 1000 rupees also, 2000 rupees also, 5000 rupees also. Okay, so the only difference is ink and design. Okay, so you can also buy 1 rupee pen also, you can also buy 5 rupee pen also. Okay, so like a majority of the students, what they are using nowadays, whichever is very less costly. Even if we go to nearby shop to buy a pen, okay, even I'm when I was a student, so buy a pen also, if I go to buy a pen also, I will grab a pen with a very less cost, say for example 5 rupees. Why? Because I can utilize that pen for more time. Okay, I can utilize that pen for more time, and also very less costly. 5 rupees means less costly, and I can you utilize that particular pen for more time. Okay, so what I can see is reliability, how reliable it is coming, so how far it is coming. Okay, how far it is coming, how many days it is coming, or like in some advertisements you can notice like that pen can write for 1 kilometer, 2 kilometer, 3 kilometer, like that. Okay, so based on the, okay, based on the content, based on the amount I will choose as a consumer. Okay, but in my mind, not only in my mind, majority of the students mind, if they go and take one pen now, so what the first concern what they will come up with, okay, first constraint, that is the cost only. Okay, so next only they will write. So first we'll take 1 rupee pen, 2 rupee pen, 5 rupee pen, 10 rupee pen, like that. So what it will do is we'll write and see. Okay, so how the ink quality will be like. Okay, so if the 5 rupee pen will write and see, 10 rupee pen will write and see, then 2 rupee pen also will write and see. Okay, so which pen will take the most now? Will take the 2 rupee pen only. Because why? Because we can easily write and we can easily throw that pen. Okay, no need of refilling again. If you again buy one refill, again it might cost again 5 rupee or 10 rupee, like that. So simply what they will do is we'll buy a pen with a low cost, we'll just write and we'll just throw it away. So in there our constraint is getting the pen with like with a less cost and optimal cost. Okay, and also that pen has to work for very long time. Okay, like minimum it has to work for 1 week. 1 week, if you take one pen, it has to work for 1 week. Okay, so instead of buying a 10 rupee pen, what we can do is we can take the pen with 2 rupee cost, and we can write it for because even 5 pens we get 4 pens we can get more. Okay, if you buy 10 rupee pen also, you can it does the same. Only the thing is that ink quality will change. Okay, say for example, if you are writing an exam, then we'll buy a pen with very good quality. Normal for rough notes and all, we'll take the pen with very less costly. Why? Because we are not going to utilize that notes and all, just for practicing and all. So there the constraint is to buy a pen with very less cost. Okay, very less cost, and your objective also will be satisfied. Our objective is, what is our objective? To write something. Okay, write something. But at the time of exam, our objective is different. Okay, we have to write correctly, and we have to take the pen with very good thing. Okay, very good refill and all, ink quality, like that. Okay, so that the objective is changing. So here normally the, so majority of the consumers, so like if you want to design any product, if you want to design any product in the world, say for example your mobile phones, it might be very sleek, design are very sleek, then weight is very less, so that product only will get. Okay, and the very important thing, if you are buying that mobile phone in any online site or in through the shops, what we'll do is, we'll go, first of all we'll go to the shop, we'll tell one range. Okay, that is our constraints. Okay, we'll tell one range, we want to buy that particular mobile phone within this range, like from 10,000 to 15,000. That is our range. Then only we'll look onto the software, then RAM, then memory, everything, and we'll tell. Okay, so within this cost, I want this many, 48 megapixel, 64 megapixel of the camera. Then primary camera, I want 16 megapixel or 32 megapixel. Then RAM, I want 6 GB or 8 GB. Then memory, I want 128 GB, like that. We are telling the or sometimes what they will do, we'll go with the constraint, cost constraint will leave. Okay, we'll take all, will compare all the thing. So whichever is we'll tell only the specification. Then apart from that, so we'll have more rupees now, we'll buy that more amount now, we'll buy that thing. Okay, we'll not see the cost and all. So sometimes what will do is, cost constraint will go. Okay, first we'll decide the cost, and for that cost we'll tell one specification, we'll compromise with some specifications. Okay, sometimes your camera quality might be less. Sometimes our RAM size will be this. Based on the cost, we'll compromise. Okay, so that is also, so while manufacturing itself in that company, while manufacturing itself, what they will do is first constraints is the cost constraint. Why? Because if they come up with that cost only, they may succeed in the market. Any company, not only the mobile. So whatever the engineering the company might be there, whatever the company might be there. So if they compromise with the cost and also with the quality, so within that cost, they have to restrict. They have to come up with the almost all the quality, like decent things, decent specification. They have to add with the less quality. So then only they might be succeed in the market. Okay, they might be succeed in the market. Then only they may get that particular product in the with the less cost. Okay, so this is how any engineering design. If you in the future, if you are working in a R&D company, okay, research and development company. So what you guys will do definitely. So you have to search for your competitors. Okay, who are all the competitors? Okay, so yeah, competitor A, B, C, D, E, F. Like the competitors might be of many, but you have to grab the competitors to choose your range. Okay, so you are in which range? So who are the competitors? What they are giving the specification. So what is the cost of that particular product? How we can optimize and how we can reduce reduce that same cost, and with the more specification enhance, like that we will decide. We have to decide, and then only you can survive in the market. Okay, any company. So how they are surviving in that sense? If they say, even if you take like mobile phone apps. Okay, mobile phone apps. So while downloading the mobile phone apps, what we guys will do, first of all we'll look on to the memory size only. Okay, then if it is free only, we'll download from the Google Play or some other license thing. Okay, so if it is licensed one, then and also if it is free. Okay, if it is cost like 100 rupees, 150 rupees, we will not purchase that particular app, and will download, and we can do it. If it is free now, then definitely more users will download. So some apps are coming with charges. Okay, even if you pay like 100 rupees, 150 rupees only, you can download that particular product, and you can utilize. Okay, and something are coming up with the very free. So what we will do, we'll download with whichever the app will have less memory only, will download. Okay, less memory. If we go for more memories, if the app is like a 200 MB or 250 MB, nobody will download. If the app is similarly, if the app is like only 10 MB, 15 MB, so the download will be like anything, like million, 10 million, 100 million, like that. More people will download, and will utilize. So in there, what is the constraint of that particular app developing company? So they need to design that app for very less memory, and with more features. Okay, the features might be of very more. Then only they will survive in the market. Otherwise they won't survive. Okay, if they come up with the app with the 300 MB with the same features, so nobody, your competitor app is having only 10 MB, 15 MB with many features, then which app will download? Will download with the less memory only. And say for example, games. I think many of us we are playing games, like Android, small games and all we are playing. So games also, while downloading the games, there are if you type one particular game in that app store, so it might come like 10 similar games might be there. So which game will download? First of all, first of all we'll see the features, some intelligent thing and all features and all, and we'll download the games with less memory only. Why? Because our RAM also will be will not sleep sometimes, so it will be very fast, like that. So similarly, like if you take any product designing, manufacturing, like any equipment manufacturing, they might be coming with like a size, they might be optimized. Then design, they may give a very optimized design, more features might be there. And the cost also very very important. Okay, so to survive in the market, cost also. If you are coming up with a sleek design, then with all the features, then your cost is more now, you will not survive in the market. Okay, so that is also one of the objective function of that particular company. Okay, so cost constraint. Okay, then your size, then design, everything should be very very less when compared to the other competitor companies. Then what is the objective? We have to give the more features. Objective will might be vary, like more features might be added. So that is also there. So yeah, if you take like any engineering problem, that might be of some certain objective, and as well as your constraints or limitations. Okay, so whatever you can say, sometimes we can say like constraints, sometimes we have to say like limits, like that. Okay, so we have to spend the amount from this, say for example monthly budget. You are going to do a monthly budget, you have to spend from like 100 rupees, or you have to spend from minimum 1,000 rupees to the maximum of 30,000 rupees, or for minimum you have to start from 5,000 rupees to the maximum of 50,000 rupees. Minimum you have to start with some 10,000 rupees to the maximum of 1 lakh rupees, like that. Some constraints we are taking, and from that we are doing our day to day things. Okay, so like that, anything in our engineering problem also. Say for example, if you want to construct a dam, like first of all, the size, everything they might be giving. Then the next is the quotation they will buy. Okay, based on this dimension, based on this volume, they may buy the quotation. So who will win the quotation? So whoever is quoting for the less, okay, less, with the same like they have to construct a dam with less cost. They only will get that like particular order. They only will get that. They only will win that particular. They only will construct that dam. Okay, so like that. So with that less cost, they can able to manufacture that particular product. Okay, they only will get, so they need to clearly mention, so which are the things, which are the materials they are using, like what is the strength, tensile strength, everything they have to mention. Similarly, if you take like electrical problems, like if you want to manufacture a new transformer. Okay, new transformer in the sense, so what we'll do, so will the size, they might be given. Okay, say for example, you need to manufacture a very small transformer to some your device. Okay, very very small, the size might be of 1 centimeter. Okay, so 1 centimeter you have to manufacture the transformer. Okay, so that is the order is being given to you. Okay, you are the 5 members are there. Okay, 5 different members, what they are, so one member is quoting like 100 rupees, another member is quoting for like 75 rupees, another member is quoting for 55 rupees, another member is quoting for 120 rupees, another member is quoting for some 300 rupees. So who will get that particular manufacturer to take that manufacturer na? So those who quote with a very less cost, say 55 rupees. Among 555 rupees is the very less cost. Okay, so whoever is quoted that 55 rupees can get that order. Okay, so you can manufacture like anything, that particular. So but if while manufacturing, okay, you can still manufacture. While manufacturing, you have to manufacture your that transformer has to does the job. Okay, it has to do that particular job, but you have to mention the constraints clearly. Okay, so even in that particular transformer, the winding you are manufacturing with aluminum, whereas 300 rupees one member claim, no. So that person is manufacturing that same transformer with copper. Okay, so this also that's the same job, that also does the same job. Okay, so what is the difference in the sense the lifetime? Say for example, this aluminum coil may come up with some, say for example, it may come up with 2 years. Now that copper coil may come up with some 3 years. So 1 year it might be increasing. So number of hours, number of operating hours. Okay, so daily 8 hours you are utilizing that particular product for 2 years. So this also daily 8 hours you are utilizing for 3 years. So number of hours might be varying. So 8 into 365 into 2. So here also 8 into 365 into 3. So number of operating hours might be increasing. Okay, if you go for the copper coil, but the cost is more. 300 rupees there, here it is only 55 rupees. So okay, so if, with the 55 rupees you can go for even for 300 rupees is where 55 rupees is where, so you can buy some 6 products, 5 products more than that. Okay, so 5 products. So here if you buy that is costly 300 rupees, here it is only 55 rupees. You can buy 4 more products. Okay, so totally out of 300 rupees, you can buy 5 to 6 transformers here. Okay, so 6 transformer you can utilize for 10 years. There only 1 year, because only 300 rupees that transformer cost is. But even though the quality, everything is good. Okay, who will survive in the market here? Definitely those who are quoted less, and the lifetime also somewhat moderate, 2 years. That the lifetime is even though 3 years, but the cost is 300 rupees. Here the lifetime is 2 years. The cost is only 50 rupees, 55 rupees. So who will survive in the market? So those who quoted less, those who are manufactured with the less cost. So this is only the optimized engineering design, optimized engineering wherever you can go, wherever the product you can manufacture. Okay, so this is the secret behind all the companies, all the R&Ds, all the research and development companies. They are working on to this only, optimized design, optimized design. They are like, even though your phone, your mobile phone, smartphones, they are coming up with a sleek design with a very less cost. Okay, 5G. 5G phones it's going to come in our country. Okay, within it already came, but even though the cost is very high. Okay, so even if they going to manufacture that same 5G phone with some 10,000 rupees to 15,000 rupees, okay, then yeah, everybody like within some 1 or 2 years, like 80 to 90 percentage will switch over to that particular 5G phones. Okay, then that mobile markets also, already came, but not in all the places. Very few places it came into our country. Okay, so whereas in some other foreign companies, almost they are utilizing the 5G technology there. But here slowly it is coming. So if the mobile cost, smartphone cost will be very less, by the time they will grab the market like anything. Okay, even after 2 years or 3 years, yeah, majority 90 percentage might be utilizing this 5G phones only. Okay, so thereafter what your mobile companies will claim is that from this date, this date your 4G network will not work. So what we'll do, will we, even though we'll purchase the all our will switch on to that 5G phones. Then everybody have 5G phones. Then that so that is the engineering technique, and as well as even though they have come up with a very sleek design, then everybody will go to that particular. So even the battery design of the your cell phones, battery design. So battery design, battery with only designing the your sleekness of your phones or smartphones. If the battery width is very less, then you can make very thin phones. Okay. And if the battery cost and if all the processor, everything, the cost is very less, you can simply manufacture that phone for very less amount only, very less cost, and you can come up with that design. So that is the key technique in all the engineering design. So in every engineering design, you can see like the optimization plays in a very big picture. Okay, so without that optimized design, no product in this world it is there. Okay, so even though we are also our human brain defaultly it is we are what is our biological name, like homo sapiens we are. Okay, so we are also thinking in that way, optimized way only. Okay, optimized way only. Even if you go to a nearby shop to purchase anything, so what we'll do, we'll compare all the things. Okay, we'll compare all the things, and we are purchasing whichever is the less cost and it serves the purpose. First of all, it has to serve the purpose, and with a less cost, what is that, then that only will buy. Okay, so that is the key technique of the your all your marketing companies, all your products, manufacturing companies, everything, any product in this world, it is following